Hey, Mr. Richards here. Let's take a look at the 6th grade Unit 6 Lesson 14 anchor problems, our last anchor problems of the 2019-2020 school year. Jordan is 2 years older than her sister Nora. Let J represent Jordan's age and N represent Nora's age. Well, Jordan is going to go right here. And Jordan is our J, and Nora is our N. Now, sometimes it's easier to actually make the table before we write an equation. So if Jordan's 2 years older, Jordan, let's say when Jordan was 2, that would be Nora was just being born, 0, because Jordan's 2 years older. When Jordan was 12, Nora was 10. When Jordan's 22 years old, Nora's 2 years younger. So that would be, about 20. And when Jordan's 32, Nora would be 30. Again, looking at it, Jordan is always 2 years older than her sister. Now it's maybe easier to come up with an equation. J is equal to whatever Nora's age is plus 2. That's how you make J equal N. That's how you make Jordan's age equal Nora's age. You have to add 2 to Nora's age to get to Jordan. Now, as we come to make a graph of this situation, or at least plotting the points, sketch a line coming down here, and just a really nice straight line, really sorry. Let us, in this kind of equation, it really does not matter what you put where. I'm going to put Jordan's age here, and then do Nora's age here. And these numbers I picked aren't exactly the easiest to work with, but let's see. If we count by 2, 3, 4, 2, 4. Yeah, I think we could maybe go count by 2s, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And we'll get on what we can. All right. Count up 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 takes us to 20. Again, we'll just plot the points that we can. When Jordan was 2, Nora was 0. When Jordan was 12, so 10, 12, Nora was 10. That would be here. When Jordan's 22, which is here, Nora was 20. So that'd be right, not there. Ignore that one down there. There. And so you could almost imagine a line being drawn in right here. For their ages. The table below shows the output values for different input values. Which equation represents the relationship between the inputs and the outputs? Let's take a look at what's going on. To get from 1 to 6, it looks like I'm adding 5. Does that work on the next one? Is 2 plus 5 11? No, it's not, is it? So we can't say our rule is just adding 5 like it is right here in A, huh? Can't just say that it's the x plus 5, because it works for the first input, but it does not work for the second input. Well, what is taking place in the second input? Let's just go there. It looks like we're adding 9. But does that work here? Looks like I'm adding, that's not going to be it. I'm not adding 9 for all of them. The thing about these rules are they have to work for all. So we're not adding 9. 4x plus 3. That seems complicated. Let's take a look. 4 times 1 plus 3. Well, 4 times 1 is 4, plus 3 would be equal to 7, so it can't be this one. 5x plus 1 equals the y. Let's see, 5 times 1 plus 1. Let's see, 5 times 1 is 5, plus 1 is 6. That works. Let's try the next one. 5 times the input of 2 plus 1, does that equal 11? 5 times 2 is 10, plus 1 is 11. Seems to work for the first two. Let's just double check the next couple. 5 times 3 plus 1, that's 15, plus 1 is 16, so that works. 5 times 4 plus 1, that's 20, that's 21. So it is going to be D, 5x plus 1. Again, just by guessing and checking. Now, if you had to come up with the rule, one way to do so is to take a look at what is going on as my inputs increased by 1. What is taking place with my outputs? Well, my outputs went up by 5. And this is getting into some early slope ideas here, but if you think about the change in y over the change in x, the change in y here was 5. The change in x here was 1. And so we could start our equation by saying y equals 5 divided by 1 simplifies to 5x. Now, of course, if you go and go 5 times 1, that's 5. 5 times 2 is 10. So what do we need to do to finish it? Well, 5 times 1 is 5. You add 1 to get to 6. And just a way, in case you weren't giving a multiple choice and interested, where is this going? That might be more of a 7th and 8th grade thing as we get going down here, but it's good to know now. Zoe is collecting books to donate. She started with 3 books and collects 2 more each week. She's using the equation B, books, equals 2W, weeks, plus 3, where B is the total number of books and W is the number of weeks she's been collecting books. See, it's right there. In the independent and dependent variables. Fine. The independent? Well, the independent variable is going to be the number of weeks. Usually can't control time. The dependent variable is going to be the total number of books. The total number of books depends on the number of weeks you were collecting those books. And so, create a table and use it to graph. We're going to put weeks, which is our W first, our dependent variable. Then we're going to put total books here second, our independent, or sorry, our dependent variable here, sorry. Independent variable, weeks, dependent variable, books. Well, I like to start with 0. In 0 weeks, if we take a look at 2 times 0 plus 3, again, using that idea of 2W plus 3 is going to equal the number of books. 2 times 0 is 0. Plus 3 is 3. In other words, at 0 weeks of time, she has those 3 books she started with. What about 1 week? In 1 week, okay, 2 times 1 is 2, plus 3 is 5. 2 weeks? I forgot to write that down. 2 times 1 is 2, plus 3 is 5. 2 weeks? 2 times 2 is 4, plus 3 is 7. And lastly, in 3 weeks, 2 times 3 is 6, plus 3 is 9. And so we can go from the equation to the table, now to the graph. Our dependent variable, or our independent variable, excuse me, is our weeks, and that's going to go on the x-axis here. Our dependent variable goes on the y, so books, which is our b. And we can just really go 1, 2, 3 here. And we can count by ones going up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 0 weeks, 3 books. 1 week, 5 books. 2 weeks, 7 books. 3 weeks, 9 books. And there is your graph. And that is it for these notes and for this year. Good luck.